In this practice, we are going to go over a question in circular motion. A particle is to slide along the horizontal circle path on the inside of the funnel. The surface of the funnel is frictionless. How fast must the particle be moving in terms of r and theta? Okay, this is supposed to be theta if it is to execute this motion. Now, this particle is moving in a horizontal circular path in a funnel as it gets to go down. Now, if it is to execute this motion, what will be the velocity v? We're supposed to move at that angle theta and the radius here r. Now, let's break out the motion which we have here. We can form this triangle. We have got the angle theta at this point, and then we have got the radius here r, and then the particle is at this point. Okay, now what are the forces which are acting on this point? We have got the weight force of the particle mg, and as we can see, the surface of the funnel is like that. So that means it makes 90 degrees. There is a normal force here which it makes 90 degrees to the funnel. There is the normal force. So normal force is always 90 degrees to the surface. Now from here we know that if we can extend this line like this, of course this angle theta which is here is going to also be equal to this angle which is here. We can see that we are making a z. So this is also theta. Now if we extend this line like that, and then we also extend this line like that, let me extend it like that, and also this one like this. If we have got two lines which are crossing, this angle is also equal to this angle. That is one thing that we know. So that means if this is theta here, then this also is going to be theta. And really this angle which is formed here is equal to this angle which is also here. It is also theta. Okay, so that is one thing that we need to get to understand. So now my point of interest is the angle theta. This is theta at this point. Now because the normal force is at a certain angle, we need to break it in two components. We have got the upward component and also the component in this direction, that is the x component. Now to the angle theta, we can see that the x component is adjacent, so this is going to be normal force cos theta, and the y component is, if we can draw this line, this is opposite and it is actually equal to this side, so that is normal force sin theta. Looking at the net forces in the y, what is going up is normal force sin theta minus what's going down, that is mg. So the net force is 0 because it's moving in an horizontal circle in the y. And I can take mg the other side, so that would be normal force sin theta being equal to mg. And because this thing is moving in a horizontal circle, as we can see, there's always a force pulling it towards the center. That is the centripetal force. And in this case, the centripetal force is due to the x component of the normal force. So the centripetal force is equal to n cos theta. So n cos theta is going to be equal to, we know centripetal force actually is just mass times acceleration, but because centripetal force is going to be mass times centripetal acceleration, we also know that centripetal acceleration is v squared over r. So that is the centripetal force, m v squared divided by r. Now from what we have here, we know that if we divide sin over cos, we get tan. So we are going to divide this one by this one. So this is going to be n sin theta divided by n cos theta is equal to m sin theta is also related to mg, so that is going to be mg, and then divided by mv squared over r. The n cancels with the n, the m also cancels with the m. So what we have is sin theta over cos theta, that is tan theta. And what we have is g divided by v squared over r. So I can also write this as g times r over v squared. So this is going to be gr over v squared. To remain with GR or to remain with V, of course this is over 1. So if I take this one on top, this one comes down. And then this one also comes down, the one goes on top. So this is 1 over tan theta is equal to V squared over GR. So for me to have V alone, I'm going to multiply this GR by the one there. And that will leave us with V squared being equal to GR divided by tan theta. So to remain with V, V is going to be the square root of GR divided by tan theta. Therefore, this is the formula that is going to give us the velocity of the particle. We can as well say this is the square root of GR. We know that 1 over tan theta is called theta. So that is the same thing. Well, thank you so much for watching. If that is helpful, please be sure to subscribe. You can also share the video for others also to enjoy as you get to enjoy. Enjoy your day.